turn through the fog. The mechanical principles, it's kind of fun doing these videos like this. Why didn't we do all of them in coal? It would have been way better and way more mysterious. The mechanical principles are this. You've got to bring up that steel to a point that it becomes essentially sticky. You've got to get through the oxides and silicates that are on the surface by whatever means possible, whether that be grinding or whether that be through creating a perfectly inert environment. And by having a cleaner finish, you can get a lower temperature weld. You have to bring your steel up to that weld zone, and there's a way to actually overlay a graph. You know, this is going to get a little bit nerdy for those of you who are into these kinds of things. But there is essentially a window that every steel has, and depending on the carbon content of the steel depends on how big that window is. So the lower carbon, like wrought iron's a weird one because it has carbon in it, but it's kind of not really well alloyed in. But mild steel and those kinds of things have a very broad window. So say your forge welding temperature starts around 1800, and maybe we'll go up to about 2300, 2400, and at that point you start getting basically burnout. Something like 1095, that window's way shorter, so the temperatures come up a little bit. Yeah, it's come up a little bit, and it's also come down a little bit on that top end. So its window is like this, but mild steel is like this. So if you're trying to forge weld mild steel, which has a broad window, and a high carbon steel like 1095, you've got to get it right in this window in order to get that perfect mating. And if you're alloying or you're forge welding other more complex alloys, you start getting issues of, say, things like chromium and vanadium that are in the alloys. So people always say that 5160s, which is essentially spring steel, is an absolute devil to forge weld. And yeah, sure, it's tricky. It's not the easiest thing in the world, but it can be done. But if you do want to forge weld, pick a combination that are well known for going well together. Set yourself up for success rather than setting yourself up for misery and gnashing of teeth. At the beginning, it's hard enough as it is. So maybe just start with mild steel. Then another thing to think about is if you are encapsulating, say you're bitting an axe or something like that, so you're putting a high carbon steel into another one, make sure that you surround them well. So say this is my V'd out split for the front end of my axe. Obviously try and balance it up nicely. Make sure that your piece that is going in there goes in there well and doesn't stick out too far in this direction. And likewise sideways, you don't want it hanging out like this, because remember, it has a smaller window and it has a higher propensity to burn, which is hyperoxidizing, and then you get the burnt crispy stuff and it all looks like bubbly nasty popcorn, and that's essentially wasted material. So instead, make that thing absolutely fit perfectly so that from the side it is 100% hidden, and from in front you might even want to have a little bit of progression on this material so that when it comes around it actually protects it all the way through, and your forge weld actually winds up being center core like that, and then maybe the mild actually progresses slightly further forward than it on the tips. That way you're getting the protection the whole way through. Anyway, those are just little things that I've found over the years. Blah, blah, blah. We spoke about Breeze earlier. This is actually quite a nice piece. It's kind of nice and popcorny, very, very brittle. You see how when it breaks, it's silvery and fluffy on the inside. That's kind of desirable. And I'm going to give a quick plug to the wonderful folks at Sidney Lee that we have down here in Atlanta. They're a weld supply company, and I believe it was, what's his name? One of our guild guys, McClure. He worked for Sidney Lee, and he got with the guys who provide the coal for John C. Campbell, which is really, really good coal. I believe it's just Pennsylvania Coal Company. Love their coal. It burns really clean. It's got very, very low ash content, and the sulfur and all that nonsense is pretty low in it as well. So it's good bituminous coal, or bituminous, however you wish to call it. Right, I'm going to prep this up for a weld. And what I'm going to do is just the same lap weld as we were doing before, but I'm going to flux it this time. A little bit of heat in there should do it. I did a little bit of prep when I did my last cut off. So I cut it from one side. I'm just pushing in that tip to keep it nice and narrow. Fold it that way for a change. Nicely laid on. So I folded it this way for a little bit of a difference. I wanted to see if this piece will push in a touch as it creates the weld and give it a little bit more flatness. There's all kinds of really fun joints that you can create there. Give this a couple of spins, just let some heat soak into it, and then I'll scribble on the board. So, in your joints, how to create the volume that you might want. That you might want in your joint. You could actually kind of create a keying, like, I'm trying to remember how this goes. There we go. You can create a keying of two pieces like this. So you've upset this portion here so it's larger. That comes in, same here. So that when you create that joint, if this is, you're putting two pieces together, you're essentially doing this, right? And you're getting more surface area on your joint, and you're also getting additional volume, so that when you dress that material out, it comes back to true square. And you can actually calculate your expansion and all those kinds of things based upon the volume, but that is really beneficial, because whenever you bring two bits together, you're going to get wasting, because there's always degradation around the outside. So you have to create more than the volume you need in the weld that you're creating. So if you can get a little bit of upsetting before the material, that means that when you come in and neck that mass down, even if you've lost 10% in the forge weld, it's okay. It's all making sense, Jess? Are you with me?
It's making sense to me. I think it makes sense to other people, but hey, if you're confused, just shoot us a message and we'll make another video to explain it better. How's that sound?
We're making videos forever.
We'll make videos forever.
Pushing in those little ears there.
So again, you're just getting this prepped right now. You're not actually welding it yet.
But you see how I push that in to create that little bit of a divot through this portion? Mm-hmm. It just kind of creates a little bit more of a physical mass. And this might increase the likelihood of getting that weld joint down in that lower portion there. Okay, I'm going to drop a little heat into it, give it a wire brush, and then flux it. Regarding flux, there are all kinds of magical solutions for, the perfect weld and all the rest of it. As I said, I've done everything from white builder's sand, so silica sand, to broken glass. Works fair. It's not awesome, but it does work. It's very clean. I've used borax, just regular mule team, was it 20 mule team borax. there is boric acid, and I think the difference between borax and boric acid is one is anhydrous, which basically means you cook your borax, your borax until it becomes like a glass, and then you crush it up again. Make sense? So when I'm warming this up, if you've been forging and you use a wire brush a little bit, you'll notice that there's a temperature where this thing is so vigorous, it's trying to forge weld on me. But you'll notice that there's a temperature where the scale just pops off beautifully. It doesn't even have a bond to that surface. That is the temperature that I'm trying to get it to in order to wire brush it, so that I've got as much of that dross out of the way as possible. I'm going to close that joint a little bit. Here's a fun one for you. You can flux in the fire. You don't have to lift it out. You also don't need a whole mountain of it. I'm just going to pick up that on the underside. And this is the thing about borax, is it bubbles up because it's got that water in it. But you see now how the surface has started to become wet as that stuff is melting in. I'm just going to warm it over the fire a touch so it can really melt in there, so you can see what I was talking about, wetting down. That was probably twice as much borax as I really needed. You see how that's wet down quite nicely? It's wet down into that joint there, and it's nicely through there. If I just heat this up, the nature of capillary action is going to draw that flux through everything. So I'm not trying to rush it to temperature. All I'm doing now is allowing everything to come up to temperature nicely. There's all kinds of like fun products like Easy Weld and all those kinds of things. And basically what they've done is they've put iron particulate in and other kinds of things in order to make that weld happen more likely. You can actually put pure iron dust in there. You can actually, if you use a saw, especially if you use like more of a mechanical style saw, like a little bandsaw, you can collect that metal particulate. If you heat that up in, say, like an Altoids tin, that kind of thing, a nice clean tin, and you heat it up until the oil burns off it, because there's generally oil in that surface, this thing is literally ready to forge weld. It's come up so easily. You can then use that to sprinkle in and actually use it as a filler. It's basically Bondo for blacksmiths. So I've got it pretty high in the fire so that I can really look at it. What I'm trying to do is keep this way on the lower side of my forge temperature. I don't want to get it as hot as I have with the previous ones. I'm going to start at that thick mass on the far end, get that to lay in, and then slowly ease back on my joint. I'm turning from side to side right now. That way I'm getting heat all the way through. There we go, that looks solid. It's beautiful and white. I'm getting a little bit of sparkling, you know, a touch hot, but it'll be fine. That was good weld. Little brush off, reflux, back into the fire. And you'll see here, I've got all the same telltales as the other one, but everything is just a little neater. It was easier to forge weld. There was less issue with separation. That's cool. It's gonna do, a little heavy-handed. This spoon is
Not ideal.
it's massive. This would be great if I was, you know, billeting a 5-pound billet of steel. So another coat of flux, everything's dribbling down, should be good. Remember, flux is not glue. It is merely a surface preparation to reduce oxidation. It also has a lifespan in the fire. So if you leave it in and you don't reflux, the flux will actually oxidize, and some fluxes oxidize faster than other, so they stop being protective. I remember there's a couple of products that I've used over the years. Remember that red one that we used up at John C. Campbell? Literally, you put it on and it never gets wet. It's just always kind of crispy. It throws down a really good weld. It allows you to forge weld at quite a low temperature, but you have to brush it off immediately. As soon as you've done the weld, you brush it off, you reapply. It's just a thing. But you'll get to know the products that you use. And your first weld, don't try and do a crazy complicated weld. Understand how the pressures go into it. Understand your temperature. Just doing this, folding up bars or getting 2 bars, laying them one on top of the other, forge welding them together. That's a really good way to learn how to do forge welds. Maybe make yourself a fork, Just flipping it back and forth. The principle of this doesn't change if you're in a gas forge. I could be running it in the gas forge. The problem with the gas forge is you get so much hot. Doing little detailed welds like this is just tricky. All right, that is lovely. I haven't got any sparkles going on, but I know I'm up to temperature. Starting at that far end. Notice how gentle I'm being. Also, don't overwork it in the side, in the shear, because if you work it too much in the shear, especially if your material is uneven, it will fail. Okay? I'm going to leave that one at that. It seemed as though it went down really, really well. That little bit of flux there. Cleaning and centering everything. There you go.
That's a very nice lollipop.
That's a little lollipop. You're always going to get that little telltale. It's virtually impossible to blend that out. If you use a little of the magic metal particulate, you can get that to completely disappear. But it's part of the beauty of what a forge weld is. Okay? I hope that makes sense. Go try some. Go burn some bits of metal up. Oh, I should show what a sparkler looks like. I might just do that as an extra.
Okay.
All right? Cool. Give it a whirl. And remember, don't cool these off. Let them cool down naturally.